Good day, everyone. Welcome to Tutors. So today we're going to talk about the third series of our resistivity interpretation. Resistivity log interpretation is kind of interesting, and yeah, we're going to continue on that. So before moving to the resistivity log and that, okay. So now for resistivity log, we've talked about the scale, talked about how to get your uh like how to determine your scale using the logs, okay? So we know how to get our scale, how to interpret it. We know that we're dealing with logarithm logs, okay? Logarithm scale, logarithmic scale, which is everything is increasing by a power, okay? 10 raised power 0, 10 raised power 1, 10 raised power 2, 10 raised power 3, like that, like that, like that. So if you have 0.2 here, you have 2, you have 3, sorry, 2 get 3, 20, you have 200, you have 2000. Okay, in between you are going to improving linearly. So between 0.2, so between 0.2 and 2, you're going to be moving 0.2 is same as what? 2 times 10 is power minus 1. You're going to be improving by what? 10 is power what? Minus 1 increase, which is what? 0.1 increase. You have what? 0.3, 0.4, 0.5, 0.6, 0.7, like that. Till you see 2. Okay? And it's because here we have like what is in between is 10 lines. So let's say you have like 4 lines or 5 lines. You have to now to check between them. I taught you about scale. Like for you to get the increment, it's because we have 10 lines. That's are moving from 0.2 to 2. Are you with me? Because probably we have 10 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Okay? So that's why we are increasing that way because you are just subtracting this from this and getting the increment. Okay? And so that it worked. Um, yeah, between 2 and 20, you keep counting and you get 20. 200 or so, keep counting and get your final answer. So, like that, because 2 is 0.2, you count by what? 0.1 increase because that's 10 is power minus 1. Because this one is 10 is power 0, 2 times 10 is power what? 0. That's 1. Have you? 10 is power 0 is what? 1. So, next one, 3, 4, 5, 6, like that. 20, 10 is power what? 1. Increase by 10, 30, 40, 50, 60, 70. 10 is power 2, 200, have you? 2 times 10 is power 2, that's 200. So we'll be increasing by 10 is power 2, which is 100, have you? 200 plus 100, 300, 400, 500. Like that, and you'll be fine. Okay? So now, I know that I've covered enough of that. And we need to look into one or two things. Okay, for which is saturation, or what they call water saturation. So our quantitative calculation is water saturation. So water saturation. Okay, water saturation. We use SW. We also have hydrocarbon saturation, which is what? SH. This one is hydrocarbon saturation. But most time we solve for our water saturation and get our hydrocarbon what? Saturation easily. So let's see how to get our water saturation. Okay, in our reservoir. So for us to solve for it, our formula for water saturation is given as SW is equals to square root of formation factor times RW over RT. Okay, what's our RW? We've done it before, right? That is the resistivity of formation water. Resistivity of formation water. Resistivity of formation water. Okay, and RT is known as the what? Resistivity of the formation or true resistivity of information. Resistivity of the formation. Okay, so RT. Now, question: how do questions come out for this? They'll tell you questions come out in a way like this. So you'll be told to find, okay, determine determine SW saturation of water using single data point. Using what? Single data point. Using single data point. Determine SW using what? Single data point. So for you to get um, SW using single data point, one single data point is talking about how you're going to get your RT. Okay? Because basically, your RW, you've gotten your RW already. Okay? Resistivity of formation water, right? And remember that in that RW formula, we look for R naught, not RT. But because anytime we're looking, we are using RWA method. Because we are using RWA method, uh, R naught is equal to what? RT. Okay, so that we find the word, because what we're looking for is resistivity of formation water. So R naught there in that formation is equal to what? RT. Okay, R naught is equal to RT at that particular region. Okay, R naught is the resistivity of the location where water is, it is fully saturated with water. Okay, so in the RWA method that we solved in the earlier video before this, we saw that uh, since R naught is equal to RT, then RT is equal to F times what? RW. That's how we got our what? Our RW. Okay, so this when you've done that, this RW is what you now use in this equation. But you're not gonna say that RT is what you are going to use here, because when you are looking for water saturation, you're looking at water saturation for deformation, not just clean side or smooth side for deformation. Okay, so we look at saturation of water. So what's the water saturation? Okay, and that formation. Okay, so now formation factor. So we've gotten our RW. Since we are still using the same composite log, are we? We're still using this log. We've gotten our RW already. How do we get our RW? We check for where we have the cleanest sand, okay? Which is because our formula is what? RT is equals to F RW. And we know that R naught is equals to RT. So we look for R naught in RW method. Okay, so R naught looked for R. So we just look for where we have the cleanest API, the lowest API, where we have the cleanest sand, that's the lowest API, and correlate it to our what? Correlate to our resistivity log where it cuts the reading that is moving. Then we'll correlate it up where that reading is, and we got 7 ohm meter. So it's because R naught is equal to RT when we're doing the RWA method, so we got RT easily. Our formation factor, I say I'm going to discuss about that because it's near time for us to talk about neutron density, 1 over neutron density. That's the formula for formation factor. Okay, we're going to come back to formation factor calculation. Okay, but let's look at how we solve for, I told you that when you're looking for a single data point, or when you're solving for water saturation, you don't use R naught equals RT, you will fail it. So how do you get your RT using single data points? That's what we're going to look for. Okay, in this place before we now move to our neutron density log in the next video. Okay, so now for our RT, how do we go about RT? Using single data points. Okay, so you go to your, some people make sure that the way they do their own stuff, they want to find RT. They'll go to where you have hydrocarbon information and probably trace it up. Okay, like this. So just trace it up and get that reading. Okay, they'll get the reading. So what would that reading be? So look for where we have the highest hydrocarbon reading. So using single data point means you are just going to look for around this, this where we have your peak, Abby. The point where you have your peak. This point is where you have your peak. Okay, in the reservoir, in your resistivity peak. So along this resistivity peak, you are going to pick minimum of two data points and find the average of it. Normal, some people just pick the highest, but that will not be really accurate because it might still have some error. Okay, so we want to reduce uh, our errors. So that's why okay. So after picking your points, so let me use a new paper to do that. So I'll still come back to the log, but let me just give you an overview. So this guy that look like this. Okay, look like this. Okay. So you just come to the peak. You know this is where your reservoir starts from. Have you? This top of your reservoir, this bottom of it. So you come to the peak in your resistivity log. Come to the peak in your resistivity log. So around this peak, you pick like around these peaks, you pick like 2 to 3 data points. So I can pick two, I can pick three, you can also pick four. So well, 2 to 3 is quite feasible. Just pick around the peak. You pick the peak and you pick like around the peak also. It will not be far off, yeah. So after that, you get the regions. So what are those peaks you've picked? You trace it. You know this is your scale. Your scale that is like this, have you? So you get what does this point mean in my scale? What does this mean in my scale? You take it down. What does this mean in my scale? You take it down. What does this mean in my scale? You take it down. So your RT will be the average of all your average. So this is how to get using single data points. Okay, you find the average. So let's say because this one I pick 3 now, that I'm doing divided by 3. If it's 2, you pick the one just be R1 plus R2 divided by 2. Just try to just figure out. Most people just pick the peak, okay, and get it. That's how you get your RT. Okay, so let's come back to our logs and see how it works. Yeah, so let me just do our logs very well so you can get it very well. So here is 2, right? Here is 20, right? Here is what? 200, and here's 2000. Okay? 0.22, 20, 200. Okay? So we've talked about that already. So let's pick data points. So I like picking my peak also. I like picking the peak. I'll pick here. Can you see? I pick that place. Very, very, it's not that close. It's my pencil that is big. Yo. This is in the middle actually. Okay. So I'll pick my R1. It's kind of in the middle. My R1 is, this is 100, Abby. This is 200. So my R1 is like, my R1, 100, 200, and here's like the middle. And here's like 150 ohm meter. Then I'll come here. I'll just pick this 100. I'll pick 100. Out to 100. And I'll just pick closer to, in between those two reading. Okay. So like 120, sha. So a bit you can see lower than that. This guy, this guy, this guy. Okay, this guy here, this guy here, this guy. So just look for this reading of 150, 100, and the last one is what? 120. Okay, 150, 100, 120. So just come here and say that what? My RT. Okay, so using single data points, we got it from our data that we have 150 plus 100 plus 120 or 130. That is 120. This is 130. It's kind of close. It's closer to it. So very, very close to 150. So 130 should be okay. I by 3. And we have this 3 what? 380 divided by 3. So what would that give us approximately? So that's 1 in 80. In 8 we have 2. In 20 we have 6. And 6 I mean we have 20. So like 127 ohm meter. That's our RT. Actually, it depends on the single data points that you pick. Your RT might kind of different, but just make sure that you want to pick your RT, pick the peak also, pick the peak and point closer to the peak. Okay, points closer to the peak. That's how we go with our RT using single data points. So after getting that, you are good to go. So the any value that you get from solving with this gotten from your RW. The RW you got with RW method and RT. Then when we now learn how to get our formation factor, then you now put everything here, your square root and everything, you get the water saturation. So we've come to the end of today's video. Kindly like and subscribe. I know you've learned a lot. RWRT. Yeah. Thank you. See ya.